This is lesson 6.4, Elimination using Multiplication. Your objectives are to solve systems of equations by using elimination with multiplication and to solve real-world problems involving systems of equations. When you solve a system with elimination and none of the coefficients match on the variables, you'll have to use multiplication. So first, pick a variable to eliminate, and then multiply each equation by the other equation's coefficient on that variable. Finally, finish with regular elimination. Use elimination to solve each system of equations. Number 1. 2x plus 3y equals 6, and x plus 2y equals 5. Everything's lined up, the x's, the y's, the equals, and the constants. Now pick a variable to eliminate. The x coefficients are 2 and 1. They don't match. The y coefficients are 3 and 2. They don't match. So we'll have to use multiplication. Pick a variable, and it doesn't matter which you pick. Let's do the x's. Now multiply each equation by the other equation's x coefficient. The bottom equation has an x coefficient of 1, so we'll multiply the top equation by 1. The top equation has an x coefficient of 2, so we'll multiply the bottom equation by 2. The top equation is everything times 1, so it all stays the same. Multiply the bottom equation by 2. 2 times x is 2x, 2 times 2y is 4y, and 2 times 5 is 10. Now the x coefficients match, so we can eliminate. Since the signs are the same, we will subtract these equations. 2x minus 2x is 0, so the x is eliminated. 3y minus 4y is negative y, equals 6 minus 10 is negative 4. Divide both sides by negative 1, and y is 4. Now finish just like regular elimination. Substitute 4 into either equation, and we'll use the original equations. Pick the second one, x plus 2y equals 5. Y is 4, so substitute 4 for y. 2 times 4 is 8. And subtract 8 from each side. And x is negative 3. So write your answer as an ordered pair, negative 3, 4. Number 4. 4x plus 5y equals 6, and 6x minus 7y equals negative 20. The variables don't have matching coefficients, so pick one and we'll eliminate with multiplication. Let's eliminate the y's. The second equation's y coefficient is 7, so let's multiply the top equation by 7. The top equation has a y coefficient of 5, so we'll multiply the bottom equation by 5. On the top, everything times 7 becomes 28x plus 35y equals 42. Multiply the bottom equation by 5, and you get 30x minus 35y equals negative 100. Now the y coefficients match. Since the signs are different, we will add these equations together. 28x plus 30x is 58x. 35y plus negative 35y is 0, so the y is eliminated. Then your equal sign, and 42 plus negative 100 is negative 58. Now solve for x and divide both sides by 58, and x is -1. Now substitute into either equation. You'll have easier numbers if you choose one of the original equations. Let's do the first one. X is -1, so substitute -1 in for x. 4 times -1 is -4. Then add 4 to each side. And divide both sides by 5. Y is 2. Now write your final answer as an ordered pair, x comma y, -1 comma 2. Everything is like regular elimination, except start by multiplying each equation by the other one's coefficient of the variable that you're eliminating. Number 7. 4x minus y equals 9, and 5x plus 2y equals 8. Everything's lined up. The x coefficients are 4 and 5. They don't match. The y coefficients are 1 and 2. They don't match. Pick one to eliminate. We'll eliminate the y's. Now multiply each equation by the other equation's y coefficient. The second equation has a y coefficient of 2, so multiply the top equation by 2. The first equation has a y coefficient of 1, so multiply the bottom equation by 1. On the top equation, 2 times 4x is 8x, 2 times -y is -2y, and 2 times 9 is 18. The bottom equation is times 1, so it doesn't change. And now the y's have matching coefficients, so we can eliminate. Since the signs are different, we will add these equations together. 8x plus 5x is 13x. -2y plus 2y is 0, so the y is eliminated, equals 18 plus 8 is 26. Now solve for x. Divide both sides by 13, and x is 2. Now substitute 2 in for x into either equation, and we'll do the original first equation. X is 2, so substitute 2 in for x. Now solve for y. 4 times 2 is 8. Subtract 8 from each side. -y is 1. So divide both sides by -1, and y is -1. Write your answer as an ordered pair x comma y, and you get 2 comma -1. Sometimes it's necessary to use multiplication before elimination in real-world problems. Set up the system and then solve it. Number 2. Benji and Joel are raising money for their class trip by selling gift wrapping paper. Benji raises $24 by selling 5 rolls of red wrapping paper and 2 rolls of foil wrapping paper. Joel raises $60. Notice that number was changed from the original question. He raises $60 by selling 3 rolls of red wrapping paper and 6 rolls of foil wrapping paper. For how much are Benji and Joel selling each roll of red and foil wrapping paper? Since we're looking for the price of each type of roll, those will be our variables. We have red and foil types, so let's have R stand for the red price for the red foil, and let's have F stand for the price of the foil wrapping paper. Now look for clues in the question to set up the system. Benji raises $24 by selling 5 rolls of red wrapping paper and 2 rolls of foil wrapping paper. So we can say that 5 times the price of red plus 2 times the price of foil equals the total $24. Joel raises $60 with 3 rolls of red wrapping paper and 6 rolls of foil wrapping paper. So it'll be 3 times the red price for the 3 rolls plus 6 times the foil price for the foil rolls equals a total of $60. Now let's solve that system by elimination. Since the coefficients don't match on either of the variables, let's pick one to eliminate and we'll use multiplication. Let's eliminate the r's. So we'll multiply the first equation by 3, since the second equation has an r coefficient of 3, and we'll multiply the bottom equation by 5, since the top equation has an r coefficient of 5. Always multiply each equation by the other one's coefficient. 3 times 5r is 15r, 3 times 2f is 6f, and 3 times 24 is 72. On the bottom, 5 times 3r is 15r, 5 times 6f is 30f, and 5 times 60 is 300. Now, the r's have matching coefficients, so we can eliminate. Since they're both positive, the signs are the same, we will subtract these equations. 15r minus 15r is 0, so the r is eliminated. 6f minus 30f is negative 24f equals 72 minus 300 is negative 228. Now solve for f. Divide both sides by negative 24, and f is 9.5. So a foil wrapping paper costs $9.50. Now substitute 9.5 for f into either equation. Let's use the first equation. 5r plus 2f equals 24. F is 9.5, so substitute that in. 2 times 9.5 is 19. Subtract 19 from each side, and divide both sides by 5. R is 1. So a red roll cost $1. So for our final answer, the red price is $1 and the foil price is $9.50. So remember, if your system of equations lines up okay, but neither variable has the same coefficient, then you're going to have to use multiplication. Multiply each equation by the other one's coefficient for that variable, and then you can eliminate.